Hey everyone, welcome back to Trade Harbor. This is part 5 of our complete crypto learning series. Today, we're diving into Bitcoin mining, the process that secures the entire network and creates new Bitcoin. If you've ever wondered how transactions actually get confirmed, who validates them, and why miners need such powerful computers, you're about to find out. Let's jump in. So what exactly is Bitcoin mining? Mining is the process of confirming transactions and adding new blocks to the blockchain. Here's how it works. Miners compete against each other to create a valid block. The first miner to solve the puzzle wins. And what does the winner get? Two things: the block reward, which is newly created Bitcoin, plus all the transaction fees from that block. Think of it as a global computational race happening 24/7, where miners are racing to be the first to validate transactions and earn Bitcoin. Why do we even need mining? Why can't transactions just go directly to the blockchain? Because mining solves the double spend problem. Without mining, someone could send the same Bitcoin to two different people at once. Nodes across the network would store conflicting transactions, and nobody would know which one is real. Here's what actually happens. When you send Bitcoin, your transaction doesn't go straight to the blockchain. It first goes to something called a mempool, a waiting area. Miners then choose which valid transactions to include in the next block. Once a block is added to the blockchain, any conflicting transactions sitting in other mempools are immediately rejected. This is how Bitcoin prevents double spending without needing a bank or central authority. Let's clarify what the mempool is. The mempool is your node's memory pool, basically a waiting room for unconfirmed transactions. Every full node on the Bitcoin network has its own mempool. Here's the journey. Transactions start as unconfirmed and sit in the mempool. Once a miner includes them in a block, they become confirmed and move to the blockchain. So transactions flow from unconfirmed in the mempool to confirmed on the blockchain. What exactly is a Bitcoin miner? A miner is a full node with specialized hardware that does four things. First, it stores transactions from the mempool. Second, it creates candidate blocks, temporary blocks trying to get added to the chain. Third, it performs proof of work, which we'll explain in a moment. Fourth, it broadcasts valid blocks to the network. Here's the key distinction. All miners are nodes, but not all nodes are miners. Regular nodes store the blockchain. Miners do that plus the computational work to create new blocks. Now let's talk about how mining actually works. A miner collects transactions from the mempool and builds what's called a candidate block. This block has two parts: the block header, which contains metadata, and the block body, which contains the actual transactions. The block header includes four critical pieces. First, a timestamp, when the block was created. Second, the previous block hash, linking this block to the last one. Third, the Merkle root, a hash summarizing all transactions in the block. Fourth, the knots, a random number that miners constantly change. Here's where proof of work comes in. Mining is essentially a guessing game. Miners hash the block header over and over. The goal? To find a hash that starts with a specific number of zeros. The requirement for how many zeros is called the difficulty. If the hash doesn't have enough zeros, it's invalid. So miners change the knots and try again. They do this millions or even billions of times per second. This is why miners use specialized hardware called ASICs, application-specific integrated circuits designed purely for hashing. Why must the hash start with zeros? Bitcoin sets a difficulty target. The block hash must be below this target, which shows up as leading zeros. More zeros equals harder difficulty. Fewer zeros equals easier difficulty. The nonce is the only value miners can freely adjust. They change it repeatedly, like brute forcing a combination lock, until they find a valid hash. When a miner finally finds a valid hash, here's what happens. They immediately broadcast the block to the entire network. Other nodes verify it's legitimate. If it checks out, the block gets added to the blockchain, and any conflicting transactions and other mempools get discarded. What do miners earn? For each new block, miners receive two things. First, the block subsidy, newly created Bitcoin. After the April 2024 halving, that's currently 3.125 BTC per block. The next halving in 2028 will cut it to 1.5625 BTC. Second, transaction fees. All the fees from transactions included in that block. One more term, hash rate. Hash rate is the number of hash attempts per second. Higher hash rate means more chances of winning the race to find the next block. All right, quick recap. Mining verifies transactions and secures the Bitcoin network. Transactions wait in the mempool until miners add them to blocks. Miners perform proof of work, repeatedly hashing to find a nonce that produces a valid block hash with enough leading zeros. The winning miner adds the block and earns Bitcoin rewards. In Part 6, we're covering the blockchain itself, how these blocks link together into an immutable chain. Hit that like button, subscribe for Part 6, and check the description for our top 5 crypto exchanges with sign-up links. Thanks for watching. This is Trade Harbor. See you in Part 6.